Good morning from NASA's Kennedy Space Center in Florida. I'm Stephen Clark from spaceflightnow.com, and welcome to our live coverage of the rollout of the United Launch Alliance Atlas V rocket. This Atlas V launch vehicle will be emerging from the vertical integration facility in a few minutes' time. That's the building you see there on the horizon looking to the east at Cape Canaveral Space Force Station, about 4 miles away from our position. This Atlas V rocket is scheduled for liftoff Thursday morning during a 40-minute launch window opening at 6:29 a.m. Eastern Time, 10:29 UTC. And this mission will be launching a United States Space Force missile warning satellite, the 6th geostationary satellite in the military's space-based infrared system, or SBIRS constellation. This is a worldwide network of sentinels in the sky, essentially, that are fitted with infrared sensors to detect the heat plumes from missile launches, such as ballistic missiles. They also detect wildfires and also the heat signature from re-entering space debris, among other things. And it's a vital part of the Space Force's missile warnings and strategic missile defense network to provide data on the tracks and trajectories of missiles as they launch. And in the event of a strategic or a missile attack, these satellites would actually be the ones that large-scale ballistic missiles as well as smaller-scale tactical missiles. Again, with 6 satellites in the network after this particular launch, the network will be providing global coverage over the entire world except for the poles. These satellites are positioned over the equator, 22,000 miles up. And this is the 6th and final SBIRS geostationary satellite before the Space Force transitions to a next-generation missile warning system that's more capable of detecting new threats such as hypersonic missiles. We're now seeing the first indication of the Atlas V emerging from the vertical integration facility, with this satellite on board, again scheduled for launch on Thursday morning. As you can see, the Atlas V rocket, standing on its vertical or mobile launch platform, is now fully emerged from the vertical integration facility out at Space Launch Complex 41. You can just see the top of the payload fairing of the Atlas V sticking above that mobile launch tower. And again, this rocket is riding on rails along this journey about 1/3 of a mile or 1,800 feet from the vertical integration facility to Launch Complex 41, which is off to the left in this view. And the Atlas V rocket and the mobile launch platform appear to have stopped at this point. This is a standard stopping point after clearing the doors of the vertical integration facility to make sure everything is configured for the trackmobiles or locomotives that push this entire structure toward the pad are ready to resume the rollout at a little bit of a faster clip. Again, the rollout won't be any faster than a few miles per hour along this journey, about a third of a mile, and these rollouts typically take about an hour or so, including the time leaving the vertical integration facility or that hangar where the rocket was assembled and the final alignment at the pad. Much of the journey in between those 2 points goes a little bit quicker, but the rocket is typically slow leaving the VIF and then slow once it reaches the launch pad area to make sure everything is properly aligned, make sure that mobile launch platform is directly over the flame trench, and also to ensure that some autocouplers that lead from the ground side, the ground systems that flow fluids and propellants into the rocket during the countdown, to make sure those autocouplers are all properly aligned with the receptors on the mobile launch platform. If you're just joining us, you're looking live out toward Space Launch Complex 41 at Cape Canaveral Space Force Station in Florida, where United Launch Alliance is moving an Atlas V rocket from its vertical integration facility. That's the building you see on the right here. That's where the Atlas V was assembled over the last few weeks. That stacking began back in early July for this mission, with the lifting of the Atlas V's first stage core, powered by its Russian RD-180 engine, followed by the raising of two strap-on solid rocket boosters provided by Northrop Grumman. And then finally, the Centaur upper stage was raised on top of the rocket. And then last week, ULA hoisted the payload fairing, the 4-meter class diameter payload fairing containing the space-based infrared system satellite SBIRS GEO 6 onto the launch vehicle to complete the stacking of this rocket. As I mentioned, this rocket is flying in the This will be the 95th flight overall of an Atlas V rocket, dating back to August 20th of 2002, when the maiden Atlas V rocket took to the skies from this launch pad. This will be the fifth Atlas V rocket of the year. And it will be the 9th Atlas V to launch in this particular configuration, the 421, with a 4-meter fairing and two strap-on solid rocket boosters. The Atlas V comes in various configurations with different diameters and lengths of its payload fairing, depending on the type of satellite or satellites being carried into orbit. It comes in a 4-meter and a 5-meter diameter payload fairing, as well as short, medium, and long versions of each fairing. ULA also has the option to add solid rocket boosters. Again, this mission will have two strap-on solid rocket boosters to give the rocket an extra boost of energy off the pad. But Atlas V rockets can fly with anywhere from 0 to 5 strap-on boosters to give the rocket an extra bit of performance to carry heavier payloads into orbit, or to carry payloads into higher orbits, or in some cases for interplanetary missions into the solar system. This Atlas V rocket is known by the tail number AV097. AV097 is the tail number or serial number for this Atlas V launch vehicle. You can see the movement has picked up a little bit, heading to the north toward Space Launch Complex 41. You can see the launch pad in view here. So the Atlas V is now nearing the halfway point between the VIF, or the vertical integration facility, and the launch pad. Again, this rocket is scheduled to launch Thursday morning during a 40-minute window opening at 6:29 a.m. Eastern Time. That is 10:29 UTC. That launch is scheduled just about 15 minutes or so before sunrise, so it could be quite a spectacular launch if the skies are clear and the weather cooperates for launch at the opening of the window Thursday morning. This Atlas V rocket is one of two launches currently scheduled from the Space Coast of Florida on Thursday, just a couple of miles, or less than a couple of miles, to the south. To the right in this view, off the frame, is Space Launch Complex 40, one of SpaceX's launch complexes here on Florida's Space Coast. And SpaceX is readying a Falcon 9 rocket for liftoff from that pad Thursday evening at 7:08 p.m. Eastern Time, or 23:08 UTC, just about 12 and a half hours or so after the scheduled launch of the Atlas V rocket from Pad 41. If both launches get off the ground on Thursday, they will again launch about 12 and a half hours apart. That'll be the closest or tightest span or turnaround between two different orbital class space launches from Cape Canaveral, the Kennedy Space Center, since 1967. SpaceX's mission from Pad 40 Thursday will be carrying the Korea Pathfinder Lunar Orbiter mission, KPLO, also known as Danuri. This is South Korea's first space exploration mission, and it's a small spacecraft, about 1.2 tons or so. I'm sorry, about 0.7 tons or so, 1,400 pounds. And this Falcon 9 rocket will send this spacecraft on a trajectory beyond the moon. It's called a ballistic low energy transfer trajectory, and then the spacecraft will take this fuel-efficient path to eventually, in the December timeframe, enter orbit around the moon and maneuver into a low orbit about 60 miles or 100 kilometers from the moon's surface to conduct scientific observations. So a busy day on tap Thursday here on Florida's Space Coast, not to mention other activities on Thursday around the wider space industry, including Blue Origin's next suborbital launch with 6 passengers heading up to the edge of space from West Texas. That's also scheduled for Thursday, as well as a Rocket Lab mission with a National Reconnaissance Office payload from New Zealand, launching from New Zealand for the U.S. government spy satellite agency. That is also scheduled for Thursday morning, U.S. time, after a scrubbed countdown this morning due to high winds. So a busy day on tap with at least three orbital space launches scheduled Thursday, along with the Blue Origin's human space launch from West Texas to suborbital space. This rocket, the ULA Atlas V, is again scheduled for launch during that 40-minute window Thursday morning, opening at 6:29 a.m. Eastern Time, 10:29 UTC. The Atlas V that you see here is just on the other side, on the far side of the mobile launch tower that is moving, that you see in motion. From our vantage point, unfortunately, that tower does obscure much of the launch vehicle during this rollout. But if you look closely, you can see the top of that conical payload fairing sticking above the mobile launch platform's tower, the umbilical mast. It's heading for basically the center point between those 4 large masts, lightning towers on each side of the pad, 2 on each side of the pad, 4 in total. Those are structures that protect the Atlas V rocket while it's on the launch pad from lightning strikes. So at this point, the Atlas V looks like it's entering the pad fence at this point, and it'll continue to make a good progress if all goes according to plan up until it reaches inside the perimeter of those lightning towers. Then the progress will slow to make sure the launch vehicle and the mobile launch platform and all the various connections that need to be made with ground systems are all properly aligned. Weather conditions here in Florida this morning for rollout are pretty much ideal, with sunny skies, light winds, no weather concerns at all for this rollout this morning. The latest weather forecast we've seen for Thursday morning's launch window calls for a 70% chance of good weather, the primary concern being associated with cumulus clouds and potential rain showers that may hold the threat of lightning moving onshore from the Atlantic Ocean in around the dawn time frame here in Florida Thursday. You can see that progress has indeed slowed. The rate of motion has slowed as the Atlas V nears at the launch pad at Cape Canaveral Space Force Station. The entire structure that you see in motion very slowly out at pad 41 weighs about 1.6 million pounds. That includes the mobile launch platform itself as well as the Atlas V rocket, currently not loaded with liquid propellants. So an unfueled Atlas V, other than the solid fuel already packed onto those two strap-on boosters, which were filled with their solid propellant during the manufacturing process. As I discussed a few minutes ago, this is an Atlas V rocket flying in what ULA refers to as the 421 configuration, with that 4-meter fairing and two strap-on solid rocket boosters. This is the 9th Atlas V rocket to use or to fly in this particular configuration, the 421, and it's the 95th Atlas V overall, and the 5th of calendar year 2022. There are 22 Atlas V launches left to go on ULA's manifest, including this rocket, 21 after Thursday's launch. ULA is retiring the Atlas V as well as its Delta IV rocket family in favor of the new Vulcan Centaur rocket, which ULA says is still scheduled to debut by the end of the year, around the end of the year, although that schedule could slip into 2023. The Vulcan Centaur rocket will be launched from this same pad, Complex 41 at the Cape, which has been modified to support future Vulcan launches as well as to support continuing Atlas V missions. There will be at least several years of carryover where the Atlas V and the Vulcan Centaur are launched from the same pad interchangeably. The Vulcan has its own mobile launch platform, different in design from the Atlas V mobile launch platform that you're watching now. ULA has also installed a new methane fuel farm out at pad 41, liquefied natural gas. This is the fuel that will be used by the Vulcan Centaur's BE4 main engines produced by Blue Origin, while the Atlas V and its RD-180 first stage engine burns kerosene fuel. The Vulcan and Atlas V both consume liquid oxygen as an oxidizer. The Atlas V rocket flying on this mission Thursday with the SBIRS GEO 6 missile warning satellite for the United States Space Force weighs about stands about 194 feet or 59 meters in height from tip to tail. And once the rocket is fully fueled during the countdown, during the pre-dawn hours Thursday, the Atlas V will reach a final liftoff mass of about 969,500 pounds. That's nearly 440,000 kilograms or 440 metric tons in mass at liftoff. And the RD-180 main engine and the two strap-on solid rocket boosters will generate a combined thrust level of 7.1 meganewtons, or about 1.6 million pounds of thrust. As you can see, the Atlas V still has at least a couple hundred feet to go in this rollout. The launch vehicle and the mobile launch platform are currently inside the fence of Pad 41 that's passed inside the perimeter of the launch pad. And trackmobiles, or locomotives essentially, are actually pushing this entire 1.6 million pound structure along this third of a mile rollout journey. I mentioned that the Atlas V is nearing retirement, with 22 missions left on the books, including this one, launching Thursday morning. And as the Atlas V nears retirement, we'll be going through a series of lasts, so to speak, final moments in the Atlas V program. And this will be the final launch of the 4-meter class, or conical, payload fairing on an Atlas V from Cape Canaveral. All the rest of the missions from Cape Canaveral Space Force Station remaining on the Atlas V launch manifest will use the larger, more bulbous-shaped nose cone, which is 5 meters in diameter and made of composites. This is a metallic 4-meter fairing based on a fairing design that dates back to the early 90s in the Heritage Atlas program. This fairing is produced at ULA's facility down in Harlingen, Texas, while the larger 5-meter class payload fairings that cover the satellites during launch are produced at ULA's larger rocket factory in Decatur, Alabama. There is one more 4-meter class Atlas V payload fairing left to fly, and that is scheduled for launch on an Atlas V mission in November from out at Vandenberg Space Force Base in California, carrying a NOAA weather satellite into polar orbit, and that will be the final 4-meter class payload fairing to fly on the Atlas. After a brief hold or stop in this rollout, the motion has resumed for the Atlas V rocket heading toward Space Launch Complex 41. It's heading for basically the middle of those 4 lightning towers at pad 41. That'll be where the Atlas V comes to a stop. Again, if you're just joining us, you're looking live at Space Launch Complex 41 at Cape Canaveral Space Force Station in Florida, where ULA, or United Launch Alliance, is moving an Atlas V rocket out to the launch pad for a liftoff scheduled around dawn on Thursday. The launch window Thursday opens at 6:29 a.m. Eastern Time, or 10:29 UTC, and runs for 40 minutes. And this mission will be launching a spacecraft for the U.S. Space Force, a missile warning satellite called SBIRS GEO 6. It's part of the military's space-based infrared system, which is a fleet of orbiting platforms outfitted with infrared sensors to detect heat plumes from missile launches. And these heat plumes, these detections that are registered and detected aboard these SBIRS satellites, give military forces and the U.S. government chain of command early warning of missile launches that may threaten either the United States homeland or deploy military forces in theaters around the world. This is the 6th and final space-based infrared satellite heading up to geosynchronous orbit, about 22,000 miles or 36,000 kilometers over the equator. At that altitude, the satellite will orbit the Earth in lockstep with Earth's rotation, giving it a fixed geographic coverage zone. And with 6 of these satellites scattered around the world at different longitudes along the equator, the military will have global coverage for missile launch detections. The military already has this global coverage currently with the existing SBIRS missile warning satellites, as well as older legacy missile warning satellites that date back to the 1990s and 2000s. But this spacecraft, which is designed for a 12-year service life, will extend that coverage that's already provided by the existing satellites later into the 2020s and eventually into the 2030s. The Space Force plans to launch the first in a next generation of more capable missile warning and missile detection satellites around 2025. The military's first SBIRS GEO satellite for this missile warning constellation launched on an Atlas V rocket back in 2012. Pardon me, May of 2011 is when the first SBIRS GEO missile warning satellite launched in this current generation of missile warning spacecraft. And five of these satellites have launched in total so far. Most recently, a SBIRS GEO 5 satellite launched on an Atlas V rocket in May of 2021. And again, number 6 is on this launch vehicle that you're seeing now, waiting liftoff from Cape Canaveral Thursday morning at 6:29 a.m. Eastern Time, or 10:29 UTC. Just to get your bearings on what you're seeing in our live stream right now, you're looking at Space Launch Complex 41 at Cape Canaveral Space Force Station, where an Atlas V launch vehicle on its mobile platform is rolling out to the pad for launch Thursday. The Atlas V and its mobile launch platform is a dark vertical structure that you see, a solid structure that you see toward the right of the frame in this view. The four antenna-like structures that are sticking up out of the pad, those are lightning protection towers connected by a series of catenary wires that protect the rocket while it's on the pad from lightning strikes, which are a fairly common occurrence here in Central Florida, especially in the summertime, this time of year. The structure you see in between those lightning towers, which kind of looks like a half of a hammerhead, for lack of a better term, is the crew access tower. That's the structure that will be used in the future for astronauts who are boarding Boeing's Starliner spacecraft, which will be launched on Atlas V rockets to the International Space Station. And astronauts will ride an elevator up to the top of that tower to actually walk across a access arm and enter the hatch of the Starliner spacecraft on future missions. That first Boeing Starliner crew mission is currently slated for launch around the end of the year or at the beginning of next year on an Atlas V. The half circle or sphere that you see on the left side of your screen or the bottom of that leftmost lightning tower, that is the liquid oxygen tank for ground storage of liquid oxygen out at Pad 41. That holds liquid oxygen that will be pumped into the Atlas V's first and second stages during the countdown Thursday morning. We're continuing to see very slow motion now as the mobile launch platform, pushed by locomotives along rail tracks leading out to the pad, makes its final push. Looks like maybe 200 feet or so to go in this rollout, which is about 1,800 feet in total distance from the vertical integration facility to the pad. So of that 1,800 feet, around 200 feet left to go. If you're just joining us, you're continuing to look at a live view of Space Launch Complex 41 at Cape Canaveral Space Force Station in Florida, where United Launch Alliance is in the home stretch of rolling an Atlas V rocket to its launch pad in preparation for liftoff scheduled for Thursday morning with the United States Space Force payload. Now less than 100 feet or so to go remaining in this rollout from the vertical integration facility where the rocket was assembled piece by piece, beginning with the core stage or first stage, followed by the two strap-on boosters that will give the rocket an extra burst of energy off the launch pad. Then ULA raised the Centaur upper stage onto the Atlas V. And last week, ULA added the payload fairing containing the SBIRS GEO 6 missile warning satellite for the Space Force, which is the prime and sole payload on this mission. And following the addition of the SBIRS GEO 6 payload or satellite last week, ULA completed a series of end-to-end tests and interface verifications to make sure that the payload and the launch vehicle were properly connected and communicating with one another before convening a launch readiness review yesterday, which resulted in a go for rollout and launch this week. When the rollout is complete, the Atlas V will actually be just up against, in this view, up against the crew access tower, just to the right of the crew access tower. So it'll close that gap between the crew access tower and the mobile launch platform that you're seeing in the very middle of your screen. That gap will be shrunk, and the Atlas V will take its place right next to the crew access tower. And at that point, the ground crew out at Pad 41 will ensure that the Atlas V and its mobile launch platform are directly over the flame trench. They'll also ensure that there's proper alignment between autocoupler connectors that will flow propellants and fluids into the Atlas V during the countdown Thursday. And then the mobile launch platform jacking system will actually lower the entire 1.6 million pound structure that includes the mobile launch platform and the launcher itself onto pedestals or posts. And then at that point, the locomotives or trackmobiles that transported the rocket out to the pad will be moved out and will retreat back to a safe fallback position for the launch Thursday. Just a bit to go, maybe 50 feet or less now remaining in the rollout, which totaled about 1,800 feet to carry the rocket from its hangar to the pad this morning. The Atlas V rocket and its mobile launch platform are now in the very final phase of the rollout. The ground crew out at Pad 41 at this point should be just verifying the proper alignment as the mobile launch platform inches toward its final position. You're continuing to look at a live view of Space Launch Complex 41 at Cape Canaveral Space Force Station in Florida. Our United Launch Alliance has rolled an Atlas V rocket out to its launch pad this morning. The Atlas V is now at pad 41. ULA's ground crew may be doing the final alignments of that mobile launch platform to make sure it's in the perfect, correct position before jacking the mobile launch platform down onto the pedestals or posts at the pad. But we do expect the rollout is complete at this point. We don't expect any more significant motion. There may just be a few tweaks here and there to ensure proper alignment over the next few minutes. To recap, the Atlas V emerged from its vertical integration facility just after 10 a.m. local time here in Florida, or 1400 UTC, and it covered about a third of a mile, or 1,800 feet, in the rollout from the VIF hangar to pad 41. That rollout took about an hour or so to complete. And with the Atlas V now on pad 41, ULA's ground team will move on into countdown preparations, steps to prepare for the countdown Thursday morning leading up to the launch at 6:29 a.m. Eastern Time, or 10:29 UTC. That's the opening of a 40-minute launch window to haul this U.S. Space Force military satellite into orbit. This is the 6th geosynchronous satellite for the military's Space-Based Infrared System, or SBIRS constellation. This is a constellation of satellites that provide early detection and warning of missile launches. They carry infrared sensors to detect the thermal or heat plumes from the exhaust of missiles and rocket launches as well. Focused on strategic missile launches as well as some tactical launches that could threaten either the U.S. homeland or military forces deployed in theaters around the world. The next step after this rollout is officially complete will be the loading of RP1, or kerosene fuel. This is a rocket-grade, highly refined kerosene hydrocarbon that will be loaded into the first stage to fuel the Russian-made RD-180 engine on that core stage of the Atlas V. That's stored at room temperature and will be loaded this afternoon if all goes according to plan. And then tomorrow will be some final checks and closeouts on the pad and their launch vehicle, as well as a crew rest day to allow the launch team to sleep cycle and sleep shift to prepare for the overnight countdown that will begin late Wednesday night, late tomorrow night, leading up to the launch window at dawn, just about 15 minutes before sunrise on Thursday morning. This is one of 2 launches scheduled on Thursday from here in Florida. The other is a SpaceX Falcon 9 rocket scheduled for Thursday evening, about 12.5 hours after the Atlas V's launch window. That will originate from pad 40, just less than a couple miles to the south of pad 41, where a SpaceX Falcon 9 will lift off with the Korea Pathfinder Lunar Orbiter, or KPLO, mission. This is a South Korean spacecraft heading to the moon. It carries a suite of scientific instruments from South Korean institutions as well as NASA and Arizona State University to study the moon, to search for evidence of water ice and craters on the moon, as well as map potential future landing sites on the moon. So 2 launches scheduled 12.5 hours apart at this time on Thursday. We'll see if technical readiness and weather conditions hold and allow those launches to proceed. Both proceed on Thursday. We'll be covering both, of course, beginning with the Atlas V launch Thursday morning at 6:29 a.m. Eastern Time, or 10:29 UTC, and then the Falcon 9 from neighboring pad 40 Thursday at 7:08 p.m. Eastern Time, or 23:08 UTC. We'll have live streams on YouTube for both, as well as extensive coverage and details on the mission on spaceflightnow.com. If you want to support our coverage, you can become a member of our YouTube channel. You can do that watching this stream right now. And any contributions that we receive and your proceeds from your memberships go toward helping us continue and expand our coverage to bring you coverage like this of activities here on the Space Coast of Florida, as well as launch operations and coverage of the wider global space industry. So until next time, I'm Stephen Clark from SpaceflightNow.com reporting live from the Kennedy Space Center. We'll see you later this week.